Because it's such an important concept, I want to go over just one more time how to make this window. Because you're not always given the windows for story problems. Sometimes you're going to really have to think through them yourself. So just remember to yourself, X was time in this case, and Y were these market shares, right? And you had two different lines, so two different market shares. The highest you ever got is 30, the lowest you ever got is 8. So what I did was I typed in those equations, or I found them with regression or whatever, and I stored them in Y1 for Toyota, Y2 for GM. Then I pressed window, right there, window. Now X is time, T, so I went 0, because generally you like to see 0 if you can. And then I just kind of picked numbers for the high number, and the first time I did it, it wasn't right. I didn't get to see enough. So I just keep going until I get enough. And then the scale is just how much you want each tick mark to work. The scale is not that important a deal for us. Then for the Y's, a lot of people like to pick 0. 0 is fine. I usually like to go a little bit below 0, just because that way I can see my axis when it comes up. You'll see why. And then I like my Y max to be high enough to cover my biggest number, which was 30. So I went 35. I figured that can't hurt to go a little bit above. And then I made the scale 5, but again, scale is not important to us. And then you press graph. And then by making it -5 for that Y min, that's why this is sitting up here a little bit. And I know what you're thinking. You're thinking, Alana, why is that important? But when we get to finding an intersection point, which the instructions are right there, but I'm going to do it right now. When you want to find intersection, you want to find where those two lines meet. Okay, so you go second, calculate, right above your trace button. That's not the same thing as stat calc, just be careful. Stat calc, this is the calculate menu for statistics. That's why it's under the statistics button. When I want to calculate something about my graph, I want to use these buttons up at the top, right? Those 5 buttons are the graphing buttons. So I want second, calc, above the trace. And then I want to pick number 5, which is intersect. Okay, so I'm going to choose, either you go down with your down arrow until you get to number 5 and press enter, or you can just press the number 5, and there it is. And now here's why I wanted it. So by making it -5, I can still see a little bit. If you made it 0, then this writing right here would write over your, here, let me show you. If I make this 0, 0, right there, then when I go to second calc, and I choose intersect, it's down really, really low, and then when it starts writing, it writes over the top of it and makes it kind of harder to see. That's all. So I made my window go -5, -10, somewhere in there. That way I really am going to be able to see it. There we go. Oops, second calc, number 5. All right, now this is a little bit tricky. It's going to say first curve question mark, x is equal to this, y is equal to this, but that's not important. What's important is up here at the top. It's going to say y1. Now, some computers or some calculators will say y1 equals, it'll tell you the equation. Other ones will just say 1 or y1, depending on which edition of the TI calculator you've got. So it's saying, hey, is that y1 your first curve? You want to say yes. So the way to say yes on a calculator is to press enter. It hops automatically to the other curve. So that's y2. It's saying, hey, is y2 your second curve? You want to say yes, so you press enter. Then it's saying, what is your guess? So currently your guess is wherever this little blinky guy is, cursor. So you can move him to the right and kind of move him closer. You just need him to be kind of close to that intersection point, and press enter. And there it is. It finds it for you. I'm going to take a picture. And of course, you don't have the ability to take a picture like this, so you're going to have to draw a picture. Right? So you draw a quick sketch of what it looked like. That's how you show your work. And you say, okay, draw a picture, make it look like that, and then you're going to answer the question, which is, when did that happen and what will it mean? So you use the intersection. You found the intersection point to be 29, 22.1. So then the real question is, what does that mean? You know, what's the 29? What's the 22.1? What do they each mean? All right. So well, what was our starter year? Our starter year was 1990, right there. So 29 plus 1990 would make 2019. So in 2019, both Toyota and GM are expected to have equal market share, both at 22.1%. Right? So, because they ask what will be that share. So we'll have equal market share at, I guess I should say, at about 22.1%. Oh, equal market share of what? I suppose I should be clear. Of light vehicles, because we're not talking about trucks or anything. We're talking about light vehicles. All right, all done with that. Cool. All right, so what is an intersection point? An intersection point of the graphs of two models is where the independent variable and the dependent variable, where the two lines intersect, there'll be an independent and a dependent variable, right? And that's the intersection point, that x comma y point, right? It indicates the time when the quantities will be equal, right? So this time, 2019, is when those two values will be the same. All right, now a system of linear equations in two variables, or a linear system for short, consists of two or more linear equations in two variables. So for example, this particular one, I have two equations here. I have the top one and the bottom one, and you could graph both of them. But before you go graphing both of them, you're going to need to change the one on the top, because it's no good to you like it is. So let's take a moment and fiddle around with this for a second, make it better. So the first thing you want to do is you want to multiply by the common denominator, the least common denominator. So 6, 2, and 2 all go into 6. So what I can do is I can multiply everything by 6 over 1. All right, let me write that up. That would be, all right, oops, this 6 over 1 times that, and then you do 6 over 1 times the next one, and then 6 over 1 times the next one. So 3 over 2 gets multiplied by 6 over 1. The 1/2 y gets multiplied by 6 over 1. The 1/6 x gets multiplied by 6 over 1. And I picked 6 again because 2 and 6 both go into 6. All right, now I know you're thinking, Alana, that makes things worse. Oh, but it doesn't. Because what happens is they divide, right? Oops. Right? 6 goes into 6 one time, so you're left with 1x, i.e. x. Oops. Minus. Right? Then you've got your 6 and 2, right? 2 goes into 6 3 times. So if you put 2 into 6, they give you a little 3, right? So that's going to give you minus 3y equals, then over on the right, 2 goes into 6 again 3 times. And that gives you 9. Because 3 times 3 makes 9. All right, so then we need to solve this for y, because you want to get y equals mx plus b. So you want to subtract x. So you can go negative 3y equals negative x plus 9. So you're subtracting x from both sides, right? If you like to see it, minus x, minus x. They're not like terms on that right-hand side, so you're going to have to just write it like that. All right, then you're going to need to divide by negative 3, right? You're going to do it to the left, so you're going to have to do it to the right. The whole thing gets divided by negative 3. Oops, not negative 32. All right, so that leaves you y equals. Now over here, what was the number in front of that? It was a 1, right? It was 1x, so it's minus 1x, if you like. All right, so this is negative 1 over negative 3. That makes 1/3 x plus, oopsie, minus, because a positive 9 over a negative 3 makes minus 3. All right, so there's our other equation. Let me save this. There we go. Okay, so I've got that top equation now transformed into this part right here. Okay, and the bottom equation I didn't have to bother with because the bottom equation was already y equals mx plus b. So I just fiddled around with the top equation to get it to change. All right, now I've got to graph both of those equations. So the easy one is actually the y equals x minus 5 because your y-intercept is negative 5 and your slope is, I know what you're thinking, it's 0. No, it's not 0. Just because there's nothing there doesn't mean that there's 0, because if it was 0 there'd be no x, right? So it's actually 1x if you like, right? So your slope is 1 over 1. Okay, so let me go graph. Hold on. Here, I'm just going to do it in this program for a minute, and then I'll be able to copy and paste it back. All right, so you start at negative 5, and then you want to go up 1 over 1 because your slope is 1 over 1. Like that. Up 1 over 1, up 1 over 1. And we could keep going, right? But long and the short of it is going to make a line. Whoopsie. And that would be 1x minus 5. And let me graph it like this. There you go. All right, so there's the one line, 1x minus 5. Then I need another line. And actually, I'm going to make this one black. That's fine. Okay, now I need another equation. So the other one starts at 3, negative 3. Right? So I'm going to start at 0, negative 3. Make this all go away. Okay, so there's the other line. Starts at 0, negative 3. And it goes up 1, right 3. Right? Up 1, right 3. Because that way it'll get you your slope. So you go up 1, right 3. So 3, 2. You don't have to worry about the points. There it is. Up 1, right 3. I could do it again. So if you're graphing by hand, you start at the negative 3 and you go up 1, right 3, up 1, right 3. And I'm going to make that blue. I think that'll make it clearer. All right, now I want to make a graph of that line. So it's 1/3 x minus 3. And I'm graphing in blue. I want to make it thick. There you go. And you can see where they intersect, or hopefully you can. They intersect at 3, negative 2, right? And there you go. So the answer to the equation is 3, negative 2. So this part wasn't really the answer. It was just the equation part that you needed, y equals 1/3 x minus 3. But the actual answer they were looking for is what's the point, right? The ordered pair that satisfies this, and that would be 3, negative 2. Let's see. There you go. Cool. So what you've just done is find a solution. A solution of a system, excuse me, not just any solution, a solution of a system. A system, of course, is like I set up here when you have more than one linear equation. Actually, it doesn't have to be linear, honestly. A system is more than one equation. And then a linear system, which is the one we're going to work with the most often, is more than one linear equation. So when they're both mx plus b, or one of them might be parallel or perpendicular, or excuse me, horizontal or vertical, that's all possible. And then the solution is any point that would satisfy both of them at the same time, which in this case is just the 3, negative 2. The solution set is all the solutions of the system, which linear ones aren't really going to have more than one as a general rule, unless they're special. But you could have parabolas and stuff intersecting more than once, like a parabola could come through twice on that blue line. And then we solve a system by finding its solution set. So when I say solve this system of equations, you got to find any point where they would intersect.